Hello, welcome to Fast Physics. So, gravitational potential, what on earth is it? So, we consider gravitational potential as the potential energy that a unit mass would have if it's moving through a field. So, if we are trying to calculate it, it has a symbol V and is measured in joules per kilogram. And the way we calculate it is V is minus the gravitational constant, 6.67 times 10 to the minus 11. And times by the mass of the object it's moving away from, divided by the radius. Sorry, that is that. When we're trying to work this out, you're probably sitting there thinking, well, why on earth is it negative? And the reason for that is, if you consider an object on the surface of the Earth, so let's say if it's a nice little square box, like let's make it easy. So if it's a square box on the Earth, I have to put energy in to lift the box up. So I have to do work against the gravitational field to lift the box up. So because of that, the gravitational potential energy is going to be a negative because we're considering as well as that the energy that we're having to put in, the work we're having to put in to counteract it, to counteract lifting something through a field. If we are increasing our r, so the distance away from the object that we're moving away from, so the large mass, if this gets infinitely big, it means that this is going to get infinitely small. So an infinite distance away, our V is going to be at 0. So it's really important for you to consider that the further away you are, the less negative it is going to be. And at the surface of the Earth, it is going to be the most negative. Because you're not having to put any work in yet to lift it up. Oh, I almost forgot as well. So that's if you want to find gravitational potential. But if I wanted to find gravitational potential energy, this is the potential. So now we've got to times it by the mass that we're having to actually do the moving with. So if I wanted to find my gravitational potential energy, measured obviously in joules, what that would be is minus G times by the mass of the object you're moving away from, times by the mass of the object that's doing the moving, like a rocket, divided by the radius. So if this is gravitational potential, this is gravitational potential energy. So there is a difference between the two. So little g that we've been speaking about before is the gravitational field strength. We can use our gravitational potential energy and our gravitational potential to find our g. So if we're looking at a graph like this, as I've already discussed before, if this is the radius of our Earth, your gravitational field strength is going to be an absolute maximum here. And then as you start moving further away from the radius of the Earth, it's going to deplete. Now, the area underneath that graph, that is our change in our gravitational potential. That's a change in our gravitational potential. So we can find G using the change in our gravitational potential and using our graph, thinking about it as the area. So another way to calculate G using gravitational potential is minus change in V over your change in your R. So that's one way we can link this and that together as well as our radius. Another thing we have to consider is that because we can find out what our G is using our delta V, we should be able to use our V to find our G as well if we've got V on the axis instead of our G. So one way we can find that out here is exactly the same at the radius of the Earth. It's going to be an absolute negative. It's going to be as negative as it can possibly be. And as you get further and further away, it's going to become less negative. So it'll do this. Now, the gradient of that graph at any point, so say if I wanted to find out the point here, what you'd have to do is obviously find a tangent doing that. Now, you should have covered that when you do your required practicals, but just for purpose, straight line, find a tangent. if I find out the tangent here, that gradient of this tangent, so the m, the gradient, at that specific point gives us the value of our g. So there's two ways in which you can interchange this relationship to try and find out what you're looking for. So I know that was a bit of a whistle-stop tour, but that's basically all you need to know about gravitational potential until you try and calculate with it. So best of luck, and see you in the next video when we're doing escape velocities. Bye!